Okay, now let's have a look some DSE question related to two different topics, permutation or combination, and the second one, probability. Okay, and most likely probability can relate it to permutation and combination. So let's see some question. When you study the question, you need to think what kind of question. Okay, is it a permutation or combination? That means how many number of ways. Okay, second, probability. If this one is a probability, then do you remember the values of the probability should in between 0 to 1. Okay, so be careful. Okay, when you start to study the question, you need to think about either this one or this one. Okay, let's see. This is a sample paper. Okay, question number 16. Let's have a look. Study the question now. A committee consists of 5 teachers from school A and 4 teachers from school B. Okay, so you can highlight, okay, 5 teachers from school A and then 4 teachers from school B. Okay, now 4 teachers are random selected from the committee. Okay, so all of them, and then we select 4 teachers. Okay, this is the situation. Okay, then what is the condition now? A, find the probability that only 2 of selected teachers are from school A. Okay, 4 of them, only 2. Okay, only 2 from school A. So first, think about it. Is it a permutation combination question? The answer is no, right? Because you can find, okay, this is the probability question. A, B, 2 of them also find the probability. So you need to think not only permutation combination, you need to think about the 2 things. What is the total possible outcomes? What is the favorable outcomes? Right? Do you remember? Because probability, you need to find out the favorable outcomes as numerator, the total possible outcome as denominator, right? So let's see. Now, only 2 of them from school A. So school A, you need to choose 2 from these 5 teachers. And total, you need 4. So from school B, also need to find 2 of them. That means from 4 of them to choose 2. Right? Okay. So for, according to this situation, or this condition, should say that, okay, then the favorable outcome, we can think it like this. Okay, this one from school A, 5 to choose 2, right? And from school B, that means from 4 to choose 2. Okay, then total 4 of them. After you find out the favorable outcomes, then what is the total possible outcomes? What is the total possible outcomes? Okay, so this time probability, so you need to find the total possible outcomes. Okay, what's this? That means whatever, you need to choose 4 teachers, right? Then find the total number of teachers now. So there are 5 plus 4 teachers from school A, school B, all the schools. Okay, and you need to choose 4. So this is the total possible outcomes, right? So as a result, this one, favorable outcomes as numerator. Okay, so 5C2 comes from school A and 4C2 comes from school B, then over total possible outcomes. That means 9C4. Clear? So as a result, this one is 10 over 21. 10 over 21. Understand? Yeah, good. So let's see. How about part B? Part Next, B, find the probability that the number of selected teachers from school A and school B are different. Okay, what do you think? Difference, that means maybe, okay, from school A, maybe you think it, if 1 from A, then 3 from B. If 2 from A, 2 from B, 3 from A, 1 from B. Can we choose only one school? Yeah, so maybe all from school B or all from school A, right? So maybe you think it like this, right? So how to do this one? You found that only this situation are the same. That means all of them are different. So if the probability of selected teachers from school A and school B are different, you can use part A to find it easily, because 1 minus the complement, okay, because difference and the same are the complement, okay. So these two are the complementary events, so the required probability you can simply write as 1 minus the answer of part A. So as a result, 11/21. See? Okay. Maybe you think, can we use the combination to find out this one? Yes. Yes. So maybe you can think it. Okay. This time, total possible outcome still is 9C4. 9C4. Then maybe we choose from only school A, so 5C4. Okay, maybe you say that, is it need to write 4C0? No need, actually, no need. Okay, then what is the next? That means you can find it from, okay, only school B, 4C4, right? Only school B. Maybe 1 from school A, 5C1, and 3 from school B, 4C3. And the last one, 3 from school A, and then 1 from school B, okay? So you can choose this 4 situation, okay? 1, 2, 3, 4, okay? Let's have a look. This is 1, this is 2, okay, this is 3, and this is 4. Okay? Okay? So after that, you found that, you still can get the same result, 11/21. Okay? Okay. So this probability question can find from combination and combination. Yeah, this time is combination. No need to find the permutation. Okay? Maybe you think that, can we use the fraction to find out? Actually, yes. Maybe I show you the alternate method in part A. Okay, this one is the alternative method. Okay. So this one, the required probability, how to think it? Okay, you think it, all of them 9 teachers from school A, okay, from school A, 9/5. After the first one chose, then left 8 teachers. A still have 4, so 4/8. Then what is next 2? Next 2 must come from B, right? So this one left 7, and school B there are 4 teachers. And you left 6, school B still have 3 teachers. So you think it like this, right? But this one is A, B, B. You need to think. Actually, there are, maybe you can say that, okay, A, B, right? You can say is B, A, BA, and then okay. Do you know how many situation? Actually, there are 6. You need to find out all 6 cases. Then you can calculate it correctly. 10 over 21. Okay? You need to consider that 6 cases. Okay? Okay? So for part B, maybe you think, oh, is it the same? Nearly the same? Actually, yes. This 4 situation, okay, you can think it as a fraction, but you need to consider all the cases. If only A, simple, because 9 over 5, 8 over 5 over 9, okay, 4 over 8, 3 over 7, and then 2 over 6, right? This is the first one. And the second one, 4, 3, 2, 1, right? However, this 2, because this 2 as a combination here, okay? But if you think it as a fraction, you need to think there are 4 cases for each one, okay? 5 over 9, 4 over 8, and the next one, 2, and the last one is 2, okay? And also, this one is 4, and then 5 over 9, 4 over 8, 3 over 7, and then 4 over 6. Then you will think it, why need to times 4? I just choose this one as an example, okay? This one is B. A, B. Why is times 4? A, B. A, B, A. A, B, A, and B, A. So 4 of them also have the same probability. So you need to times 4. Understand? Understand? So when you consider this situation, you found that there are 6 cases. So it's more easy for you to use combination to find the probability, right? Use the combination to find the probability. Sometimes part A, part B have the relations, maybe complementary events, then you can use complementary events condition. So 1 minus the complementary events, you get the probability. Understand? Hope you understand. So let's have a look at some more examples. Okay, for example, this time. Practice paper, question number 16. And you found that most likely for section B of the DSE paper 1, okay, some usually will have 1 probability or combination permutation question. Okay, let's see. Now there are 18 boys and 12 girls in class. Okay, 18 boys, 12 girls. From the class, 4 students are random selected to form the class committee. This time choose 4. This is the situation. Okay, any condition, part A and part B will tell you. Let's see. Now find the probability. That means this time no need to think about this 2, but you will use this 2. This time you need to find out the probability. Okay, how to find it? If this class committee consists of boys only, that means you choose 4 of them, all are the boys. Okay, so how to think it? Okay, remember what is the total possible outcomes? Okay, then what is the favorable outcomes? Okay, total possible, that means there are total how many students? You choose 4, right? And favorable, you need to choose boys, all boys, that means 18 boys. From 18 boys, you choose 4 of them. Okay, so as a result, favorable outcome 18C 4 over 30C 4, right? So as a result, 68 over 609. This is the answer. Okay, clear? Let's see the question of part B. Here, find the probability that the class committee consists of at least one boy and one girl. Okay, one boy, one girl. How to find it? That means now here, boy, 18 boys, you choose one. And 12 girls, choose one. At least. Here, at least. Total, you need to choose 4. So, what can we do? Okay, maybe you say that at least one boy and one girl, then what are the left? You still have 2 need to choose, right? You need to choose 2, either boys, either girls. Okay, so any case that you can think? Yeah, correct. You can think it as, okay, maybe 1 boys, 3 girls, 1 boys, 3 girls, okay, 2 boys, 2 girls, or 3 boys, 1 girls. Okay, you cannot choose all girls, you cannot choose all boys. Okay, so 4 students will have this 5 situation, right? So how to do it? At least 1 boy and 1 girl, then yeah, the required probability, maybe you found that, oh, seems like the above total possible outcome still is 30C4, right? 30C4. Then what is the favorable outcomes? 1, 2, 3, right? So 18 boys choose 1, and then 12 girls choose 3, or 2 boys, 2 girls, or 3 boys, 1 girl, right? So you see that this is the answer, 530 over 609. Okay, besides this method, do you think you can use the above result boys only? And you see that if boys only, girls only, these 2 are the complementary events of at least 1 boy and 1 girl, right? So if you know, then you can 1 minus 68 over 609, and then minus all girls situation. That means 12C4 over 30C4. And this situation is all girls. And this one is part A, all boys. Okay, if you minus this 2 probability of the events, you also get 530 over 609. Understand? Clear? Okay, so hope you can use the combination to help you find out the probability. Okay, so let's see. So 2012, that year, asked you this question. Seems like a little bit complicated, but actually when you study it carefully, you still can find out the answer. Now have a look. There are 8 departments in a company. To form a task group of 16 members, 2 representatives are nominated by each department. Okay, that means here there are 8 departments, 1, 2, 3, 4, 5, 6, 7, 8, and 2 from each department. 2 representatives are nominated by each department. Then this one as the task group, to form a task group. And question or situation. From the task group, 4 members are randomly selected. From task group, choose 4 of them. Okay, that means from this group, 16 members to choose 4. A, find the probability. Okay, that's fine, no need to think more. to question or probability. So goes on to find out the total possible outcomes and favorable outcomes. Now, 4 selected members are nominated by 4 different departments. Oh, I see. That means from 4 departments. 1, 2, 3, 4. 1, 1, 1, 1. Okay? Okay? So, you choose from this 8, choose 4 of them, and each department choose 1 member. Understand the question? So you see that, oh, seems not difficult now. Why? Okay, what is the total possible outcomes? What is the total possible outcomes? You know that we choose from the 16 and then choose 4 of them. So total possible outcome is 16C4. Okay? No position, so you just use the combination enough. Then how about numerator? Because you need to choose 4 different departments or members. So first, there are 8 departments, right? You choose 4 of them, okay? Then times first department, you choose 1 of them. The second one, choose 1 of them. The third one, you choose 1 of them. And the fourth one, you choose 1 of them. So this is the answer. Clear? So 8 over 30 is the answer. Okay? Okay? So maybe you think it, how about part B? How about part B? Find the probability that 4 selected members are nominated by at most 3 different departments. At most 3 different departments. Okay, that means not more than, okay, 3. How many cases do you know? How many cases do you know? Actually, you can choose from 1, 2, okay, maybe at most is 3, okay, maybe 1, 1, 2, right? 1, 1, 2. Any more? Any more? Yeah, maybe only 2 departments. 1 and then 2. So 2, 2, right? We cannot choose only 1 department because you need to choose 4 members. So each department only have 2. So at least you have 2 different departments. At most 3 different departments. So what do you think? Yeah, actually you can think it, okay, simplest method is related to part A. Do you know why? Because complement of part A is the answer. Okay, 1, 2, 3, 4. Okay, you can choose 4 from 4 different departments, 4 members from 4 different departments. So you found that this is the first, second, and third different case, right? So this one, actually you can use the complementary and 1 minus 8 over 13. Then you can get it. 5 over 13 is the answer. Okay? Maybe we can use another method to think it. Okay? Then how to think it? Okay? Maybe it's the first situation, first situation. Okay, that means 8C2. Okay, 8C2. Then 2C1, 2C1. Okay. You still have 6. You choose 1, and we choose all of them. Okay, that means this. Okay, I will underline this one. okay, 8C2. We choose 2 departments and each department choose 1. Each department choose 1, okay? And you still have 6 departments and then choose 1 more. And 2 of them, that means all these 2 from that department we choose, okay? This is the situation, okay? So this one over 16C4, okay? And AC2, okay, AC2, and all of them, 2 of these 2 departments will choose. So as a result, this one. So you add up this 2 probability, you get 5 over 13. Still get the answer, right? Okay, understand? Good, good. So hope you can answer this question by using combination. Okay, let's see, this one is 2012, right? Let's have a look one example from 2018. Now have a look. 8-digit phone number is formed by a permutation, okay, by permutation. 2, 3, 4, 5, 6, 7, 8, 9. Okay, part A. How many different 8-digit phone numbers can be formed? Okay, part B. If the first digit and the last digit of 8-digit phone number are odd numbers, how many different 8-digit phone numbers can be formed? Okay, can be formed. How many numbers can be formed? Again, how many numbers can be formed? So, what kind of question this time? Combination? Permutation? Permutation? Okay, so you need to think which one. This time, probability? No, because you need to find the number can be formed. So let's see, how many numbers here? You need to count it carefully. 1, 2, 3, 4, 5, 6, 7, 8. 8 digit, 8 numbers. Okay, so be careful here. Now, how many different 8-digit phone number can be formed? What do you think? Because we choose all of them to form the number, so 8p8, that means 8 factorial. So 40,320 is the answer. Okay, because you choose all to form the number. Okay, so take all of them from 8 objects to choose 8 objects, get the permutation. Okay, so part A finish. Part B, if the first and the last digit of this phone number are odd number, that means now here odd and odd. From this 4, okay, you choose 2. Okay, that means C or P, C or P, because order is important in this situation, so not C. And we put it to in the first and the last digit, so 4 odd number, sorry, not C, is P. You choose 2, right? Okay, so first one, 4, choose 2. And what's next? You still have 6 numbers, right? So all of them, you need to choose. So 6p6. Okay, maybe you left 5, 7, and then 5, 7 with all even number. All of them, put it in here. Maybe you left 3 and 9, then 3, 9 with all even number, put it here. That means like this. So 6p6. Okay, so as a result, this one is 8,640. Clear? Clear? Okay, that's great. So 2018, that year, you need to find the combination, permutation. Okay, So let's see, one more year, 2017. Now this time, have a look. In the back, there are 4 green pens, 7 blue pens, and 8 black pens. Usually I write here clearly. Green have 4, blue has 7, and black have 8. Okay. And if 5 pens are randomly drawn from the back at the same time, so you choose this 5 pens from all of them. Okay. So find the probability. Okay. Probability question, right? Exactly 4 green pens are shown. Okay, exactly 4 green pens. So now here, that's the favorable outcomes, 4 green pens, but you need to choose 5, right? Exactly 4, that means the last one cannot be green, so 4 are green, 1 from the others, that means blue or black. So here is the favorable outcomes, that means the events. What is the total possible outcomes? You need to choose 5 from all the pens. Choose 5 from all the pens. Okay, so what's this? This one, that means 4, 7, and 8, right? So this one is 19, C5. Okay, how about the favorable? How about the favorable? 4, 4, right? That means choose all of them. And then 15, 1, right? So as a result, this one, 4C4 times 15C1 over total possible outcomes 19C5, right? So here 5 over 3,876. Clear? Clear? Okay. How about part B? Exactly 3 pens are drawn. Okay, exactly 3 pens. So again, 3 are green, then 2 are from the others. Okay, so this one can think like this. Okay, okay. Then how to find it? Yeah, let's have a look. 4 green pen, you choose 3. Okay, and that another 2 from the others, so 15 C2, right? And total possible 19 C5, so you get it. Oh, this time is 35 over 969. Okay, that's great. That's great. Last one. Find the probability that not more than 2 green pens. Not more than 2. That means 2 green, 1 green, or no green, right? Just now, exactly 3, exactly 4. So, what do you think? Yeah. Seems like the complement, right? So, you found that, probability not more than 2. You can think it as 1 minus probability that 3 or 4 green pens, right? So this one, you can use the result of part A and B. 1 minus 5 over 3,876 minus 35 over 969. So as a result, this one. 3,731 over 3,876, right? If you think it related to the different cases by using combination, then do you know how many how many cases, not method, how many cases? That means this one. You need to think it. Maybe I enlarge it a little bit more. 2 green, this situation. 4C2, because comes from 4 and then choose 2. And then the other 3. If only one, 4C1, and other 4. No green, that's only from other 15, then choose 5. See? So the alternate method, 4C2, 15C3 plus 4C1, 15C4 plus 15C5. And total possible outcome, no change. This one, 19C5. So as a result, this one. Okay? Okay? So you may think, can we use fraction to find out this answer? Actually, yes. Yes. And lastly, I will show you how to use the fraction to think about this. Okay? And how to think about this as a fraction. Let's see. But if you are not using the combination or permutation, actually, you still need to use. You will know why after I told you. Let's see. Part C, and one more alternative method, okay? Actually, you can think it. Okay. 19, okay. 4 over 19 times 3 over 18, okay? Only 2 green, okay? Only 2 green. Then, how about the others? You still have 17, 16, and 15. What's this? These two are the green one. Okay? And this one from the other colors. Okay? Okay? But don't miss, don't forget. This one is 5C2. What is the meaning of 5C2? That means the value, okay? The cases of 2 green and others. Okay, maybe green, green, la la la, okay? Green, la, green, la la. Green, 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 la la la, green, okay? Haven't finished yet. And total is 5C2. This 5, you have 2 green, that means this one. This is the first case. This is the first one, okay? How about the second one? Let's see. Plus, okay, I will write it to you. Only 1 green, right? Then 4 over 19. Then start from choosing 1 green already. You need to choose other color. So this one is 15 over 18, 14 over 17, 13 over 16, and the last one, 12 over 15. Okay? And finally, you need to plus no green. No green. This is the second, and the last one, the third one. See, you still need to use the combination, right? So the last one may be easy because 15 over 19, 14 over 18, 13 over 17, 12 over 16, and last one's 11 over 15. So if you use this fraction to find the probability, you also can get this correct result. Okay? See? So hope you can understand the method to find out the probability, okay, by using combination, okay, by using complementary events, okay, or count it from the combination. Maybe you still want to use the fraction to find out the probability, or method that you can use. Okay?